What's up, math fans? What time is it? It's time to learn about coterminal angles. No, seriously, what time is it? Do you know how to read a watch or a clock? Do you understand that when you look at the second hand, it goes in a certain direction? So if you're facing it, it should be going, let's say this is the clock, it should be going in this direction, like this. So this is considered clockwise. To the right is considered clockwise, okay? And to the left would therefore be considered counterclockwise, going the opposite direction of the way the hands on a clock move, all right? So we have clockwise and counterclockwise. Now, looking at angles, positive angles open clockwise. So you're gonna have your initial side, there's a vocabulary word, and you'll notice the black ray is always the initial side. That is always horizontal, doesn't move. And the reason for that is we're gonna start putting them on a graph. I'm sure you've already been introduced to trigonometry, study of triangles and angles. So we're gonna take these angles and start to put them on graphs. So this side will be flush on the x-axis, but the terminal side will change. So your initial side stays the same, your terminal side depends exactly on the angle measure. That terminal meaning ending. So if it's a 0 degree angle, the initial and the terminal side are on top of each other. This one would represent 0 degrees. Then you open it up and you have an acute angle. You remember this old review vocabulary? Acute angle is greater than 0 but less than 90. Now I have a right angle which is exactly 90. Now I have an obtuse angle which is between 90 and 180. Now I have a straight angle which is exactly 180. Now I have a reflex angle which is more than 180 but less than 360. And then if I take my terminal side starting from 0, open it all the way around and it closes back, that's a full rotation or a complete circle, that's 360. Now look at 0 and look at 360. They look exactly the same. The terminal side is in the exact same location. Therefore, 0 degrees and 360 degrees are coterminal, same location. So coterminal angles are angles that have the terminal side in the same location, which means they look exactly the same, but they have different measures, all right? These two look exactly the same, but one is 0, one is 360. That's actually important to find any coterminal angle. So let's look at 40 degrees. First graph it and then tell me one coterminal angle. So it doesn't have to be perfectly drawn to scale to understand the concept here. So I'm going to take 40 degrees and I'm going to put it on a graph. Here's my x-axis, my y-axis, my origin is here. So the vertex of the angle is going to go on the origin. The initial side goes along the x-axis, along, I guess you consider that 0 degrees, right? So here's 0 degrees. Understand that a right angle is here, so that's 90 degrees. A straight angle would be 180. If I went to this line here, the bottom of the y-axis, that's going to be 270. All I'm doing is adding 90 each time. And if I continued, I'd reach 0, aka 360. So if I'm asking for 40 degrees, there's little things you got to just keep in mind, even if you won't be asked directly. 1, what kind of angle? It's acute. 2, where would it be? In quadrant 1. Remember the quadrants? This is 1, this is 2, 3, and 4. So 40 degrees is obviously an acute angle and it's in quadrant 1, so my terminal side is about halfway up. Not quite, because 40 is a little bit less than half of 90. So here I will put my theta, or you could just put the actual answer of 40. Theta equals 40 here. That's a 40 degree angle. My question is, what is an angle that's coterminal with it? Well, the easiest answer is take this and instead of just opening it up to 40, spin it all the way around and then open it up again. So this time you did a 360 plus the initial 40 and you got 400 and even 400 degrees. So a coterminal angle with 40 degrees would be 400 degrees. And there's a formula, real simple common sense formula. You take your theta and you add 360 to get a coterminal angle. Whatever the given angle is, just add 360 as many times as you want. You can spin it around once like that. You could spin it around again and it would still look exactly the same. And then I would just be adding another 360. So you can add 360 as many times as you want. You can add it n times. Technically, you can also go the opposite direction. I haven't mentioned that. Well, I did mention that. If I went for a negative angle, I could also subtract 360. All right? So here's my formula for finding a coterminal angle. Just add or subtract 360 as many times as you want. Let's try it with a crazy number like 500. Is it acute? Is it obtuse? Is it reflex? Which one of these is it? I don't even know. But I know that this is 0, 90, 180, 270, 360. So if I spin around, here's my initial side obviously, right? And if I spin around, I've already hit 360. I'm still not up to 500. So in my mind, I should know what 500 minus 360 is. That's 140. So if I spin around 360, now I still need to go another 140. Well, 140 is going to be somewhere here, because I know that this line would be 180 and this line would be 90. So 140 is somewhere in between that. That's a quadrant 2 angle. Turns out to be obtuse. So guess what? 140 is coterminal with 500. Remember what I said? I just took my theta, I subtracted 360, boom, I got a coterminal angle. You can subtract 360 as many times as you want. You could also add 360 as many times as you want. So you can get many, many different answers for coterminal angles. Just keep on spinning. Finally, negative 40. What did we say? Notice how I keep opening clockwise. I think I said clockwise in the beginning of the video, and I should correct that. So rewind it and fix it. All these angles are opening this way, this way, this way, this way. That's actually, if you're looking at it correctly, that's actually going to the left. And if I said earlier, watching a clock, clocks go this way clockwise, so to the left is counterclockwise. Lefty-loosey, if you're tightening a screw or loosening a screw, so to the left is counterclockwise. So, hopefully I didn't confuse anyone. This one I went clockwise, this one I went clockwise. Is that it again? This one I went counterclockwise, this one I went counterclockwise. Now for a negative angle, I'm going to start at 0, but to go to negative 40, I'm opening counter. It's tougher than you think. I'm opening clockwise, clockwise. So this way, okay, the way a clock should go. So this would be negative 40, all right? And if I stuttered, I'm sorry, let me just write it down. Positive angles are counterclockwise. Negative angles are clockwise. All right? So if I want a positive angle, I'm opening opposite the way a clock would open. If I want a negative angle, I'm opening the way a clock would open, that way. Okay? So negative 40 is boop. If I was counting in negative numbers, this would now become negative 90, negative 180. Notice negative 180 and positive 180 are coterminal. Here would be negative 270, coterminal with 90, and then negative 360 would be coterminal with 0. All right? So my question is, what is a coterminal angle with a negative 40? You can add 360, you can subtract 360, up to you. I'm going to look at it like this. What if I wanted a positive answer? So what if I opened this way? What is the pink angle equal to? Well, it's equal to 360 minus 40 from that way, also known as negative 40 plus 360. And that gives me 320 degrees. So these two are coterminal. This space is 320 degrees. This space is negative 40 degrees, but they are in the same location, coterminal. All right, thanks for watching. See ya.